Hey there, everybody. I just wanted to take this opportunity to give you a video on how to solve systems of equations word problems. Now, these can be a little bit tricky because you have to write a bunch of equations and then solve them. The actual solving usually isn't too bad. You use substitution or elimination, just like you do to solve any word problems or any systems of equations word problems. But it can be tricky getting to the equations. So let me show you how that goes. So let's get up a whiteboard here, and I'm going to start with the very simplest kind. So the way you can tell that you need a system of equations is if you have two unknowns. If there's two things that you're looking for, neither of which you know, and that aren't directly related. I'll show you what I mean by directly related. So let me start with this problem. So the sum of two numbers is 35, and their difference is, what did I do here? 21. Find the numbers. Okay, so I've got two numbers here. I know they add up to 35, and that when I subtract the smaller one from the bigger one, I get positive 21. So what I want to do is start off by defining my variables. And the way I'm going to define my variables is I'm going to look for things I don't know and name them essentially. So sum of two numbers is 35, their difference is 21. Clearly the things I'm looking for here are the numbers, right? Find the numbers. It's right. It's the last sentence there. So I'm going to let the numbers be x and y. Numbers be x and y. And if you wanted to get really specific, you could define which one is bigger and which one is smaller, but it'll be pretty apparent from the problem or when we start setting up our equations. So the sum of two numbers is 35. So when I see this, let me get a highlight in color here. You, I hope, noticed very specifically the word is. That is telling me that that is an equal sign, right? And so the left side of the word is, the sum of two numbers, is one side of my equal sign, and the right side, 35, is the other one. So that tells me the sum of two numbers is 35, gives me this equation. X plus y is 35. Now I can do the same thing with the next sentence, right? Oh, I guess the rest of this sentence. And their difference is 21, right? So their difference is 21. Well, there's another is right there. That's another equal sign. So their difference would be subtracting them. And 21 is the other side of that equation. So I'm going to have x minus y equals 21. Now, notice that I sort of implicitly assumed that x is the bigger one, because when I did x minus y, I got a positive number. If you wanted to be super specific, you could have said something like, let the numbers be x and y, and let x be the bigger one, or let x be the larger number and y be the smaller number, or something like that. I think this is, as far as I'm concerned, this is clear enough. I really just want to get you to do this step right here of writing down what your variables represent. This turns out to be really helpful. Okay, so from here, we're pretty much home free, right? We're just going to solve this system of equations, and this system of equations is easy, right? You could do substitution or elimination. Both of them would actually be pretty easy in this case, but I think elimination is the easiest one because it's already set up perfectly. If I just add the two equations together, the y's go away and I'm almost done. So that's the one I'm going to do. I'm going to choose elimination here. So when I do that, I'll just add straight down and I'll get 2x equals 56, excuse me, 56. Well, divide by 2, so x is 28. And then I can take that and put it right back into either of my two starting equations. Let's say 28 plus y equals 35. Solve for y, subtract 28 from both sides, and we get y equals 7. That was easy. And that's kind of how these usually go. The questions you saw in the last section or the last topic where you were solving systems of equations tend to have harder systems to solve. And the ones in this section tend to have relatively easy ones. The tricky part here is turning the English into math, as always. And so that's what you really want to concentrate on. Be on the lookout for is's that tell you, hey, here's an equation and there's the equal sign. And do things like highlight sections of the sentence. Don't use highlighting as a substitute for understanding. Some people do that where they highlight and then they think that means that they've got it now because they highlighted it. And that's not true. You have to really think about it, right? Think before you highlight. But use whatever method works for you to understand the equations before, or to understand the English before you start writing equations. That's where you want to spend all your energy. Now, I'm not quite done with this because this is kind of a, I don't want to say sloppy, I guess maybe sloppy, lazy. This is a lazy answer here, right? The question was find the numbers. And my answer is currently phrased x equals 28, y equals 7, when it really should be the numbers are 28 and 7, right? That's really what I want to say because it was asked as a sentence, I should answer as a sentence, right? This is not just a find the number question. It's also like, picture yourself interacting with someone. Someone just rolls up on the street, rolls up to you on the street and says, the sum of two numbers is 35 and their difference is 21. Find them. Or what are the numbers, right? You're not going to answer x equals 28 and y equals 7. You're going to say the numbers are 28 and 7, right? Pretend you're talking to somebody. So that's how I'm going to write my answer. The numbers are 28 and 7. That's my answer. Okay, so I've answered it in this form, and we can do a quick check. These are actually relatively easy to check. So the sum of two numbers is 35. These two add up to 35. They sure do. And their difference is 21. Is their difference 21 if I subtract them? Yes, it is. There we go. I must be right. Okay, cool. Let's do the next one. All right, I've got the Lopez family. Family. 2 parents. 3 kids. Goes to the movies. It costs $43.25. For the 5 of them. The Smith family. Smiths. One parent, 2 kids. Goes to the same movie. For what did it cost them? $25? $25. Find the cost of adult tickets and children's tickets. Okay. This one is a little bit less obvious than the last one, right? We're going to have to parse this a little bit. So we have one family with 2 parents and 3 kids. So 2 adults, 3 kids is $43.25. And then 1 parent and 2 kids is $25. So we need to figure out how much it costs for 1 adult or for an adult ticket and how much it costs for a child's ticket. So the first thing I'm going to do is ask myself, what things am I looking for? And those are going to be my variables. So in the last sentence here, which is often the best place to start trying to figure out where to solve the problem, because that's where it asks you what it wants. It says find the costs of adult tickets and children's tickets. So I'm going to let those be my variables. The cost of an adult ticket is one variable, and the cost of a child's ticket is the other variable. So I'm going to go ahead and write that down. I'm going to say let A equal money for adult tickets. And C be the money for a child's ticket. Okay, then I can use my 2 setups here, the Lopez family and the Smith family. So the Lopez family, 2 parents and 3 kids go to the movie. So they have to buy 2 adult tickets and 3 child's tickets. And that ends up costing $43.25. So I can say that 2A plus 3C is $43.25. Similarly, 1 parent, 2 kids. So I've got 1A, so A, plus 2C is $25. A plus 2C equals 25. And I've got my system of equations. Once we figured out what we wanted to do, or where our equations were, it's pretty easy to just solve this problem. Now I can certainly do this by elimination, just for variety and to get a little substitution in here. I'm going to solve this by substitution, and when I look at the 4 variables I could solve for, this A or this A, and this C or this C, I think this one right here, this A, really stands out to me as something I might want to solve for because it doesn't have any coefficients. Right? I don't have to, like, if I wanted to solve for this A up here, I would have to solve 3C and then divide everything by 2, and then I got fractions everywhere. And that's not great, right? I don't want to do that if I don't have to. Here, all I do is move the 2C over, just subtract 2C from both sides, and we're ready to go. So that's the thing I'm going to do. I'm going to solve for that A right there, and then do substitution. So I get A equals 25 minus 2C, subtract 2C from both sides. And then I'm going to take that A, so I wrote 26, that's not what I meant to write, sorry, let me undo that, 2C. I'm going to take this, because that's A, and I'm going to put it into here. Right, that's the idea of substitution. So when I do that, I get 2 times 25 minus 2C plus 3C is 43.25. Let's clean that up a little bit. I'm probably going to need another board here. So we're going to have 50 minus 4C plus 3C equals 43.25. And this is looking pretty good. I'm going to go ahead and get another board going here. Actually, one more step maybe. Yeah, 50 minus C. So minus 4C plus 3C is minus C. So we have 50 minus C equals 43.25. Okay. Let's start over on the next board there. 50 minus C equals 43.25. And from here, it's pretty straightforward. I'm just going to subtract 50 from both sides. We get minus C equals, and when you subtract here, I'm gonna show you a trick in just a second. So this is negative 675. And I'll show you what I did there to get that. Because if you're thinking 43.25 minus 50, that's actually kind of hard to do in your head, but it's relatively easy to do 50 minus 43.25. 50.00. 0 minus 43.25. So all I did there was subtract the smaller one from the bigger one and then worry about the sign later. Right? So when I subtract here, to borrow 49, 1, and so sorry, let's try it again. That's a 9. There, that's the one I want. 10 minus 5 is 5. 9 minus 2 is 7. I haven't written out borrowing in a while. So I get 675 here, and then I have to ask myself, did I do the small minus the big or the big minus the small? And in this case, I did small minus big, so it has to be negative. Right? I'm taking away 50 from 43.25, so I'm taking away the bigger number from the smaller one, so I want it to be negative. But if I ignore the sign at first while I'm doing this, I don't have to concern myself with the sign in the middle of the problem. I just put it in at the end because I know what it's going to be. I know it's going to be negative. So that's how I'm doing that in my head. I'm not trying to do 43.25 minus 50. I'm actually doing 50 minus 43.25 and then fixing the sign, right? If I'd wanted a positive one, I would have left a positive. But since I know I want a negative, I make it negative. And then I got negative on both sides. I multiply by -1 to cancel them both out, and we get C equals 675. So it looks like child's tickets cost $675. So let's see what adult tickets cost. I'm going to go ahead and plug it into the Smith family, the one with the smaller numbers. Right? A plus 2C is 25. So I've got A plus 2 times 675 equals 25. Multiply that out. A plus 1350 equals $25. And then I subtract. So A equals, we go over here, I'm going to do the same thing, 25 minus 1350. And again, now before I even do this, I know it's going to come out positive because I'm doing big minus small in this case. And so I don't have to worry about the sign, whether it's going to be positive or negative. I just think about it beforehand and then ignore it and do the subtraction, big minus small every time. So this is what, 249. So I end up with, wait, what am I doing wrong here? That's not how that works. Sorry, I don't write out my borrowing very often, and so I'm bad when I do. 24. That's what I meant. 10. There we go. 0, 5, 11. 1150. And just like before, I don't want to just leave this as A equals $11.50, C equals 6.75, or even worse, A equals 11.5, C equals 6.75. What I want to do is answer the question in the same manner as it was asked. So find the cost of adult tickets and children's tickets. I should say one adult ticket is $11.50 and one child's ticket is $6.75. So that's how I'm going to answer the question. One adult ticket is $11.50. One child's ticket is $6.75, and that's my answer. Now, what we should really do is go back and see if this makes any sense. So the way I would do that is I would take these numbers, $11.50 for adults and $6.75 for kids, and put them back into the original situation and see if it gives me the right total. So 2 parents at $11.50 each is $23. 3 kids at $6.75 each is 18, and 225 is $20.25. So I have $23 and $20.25 is $43.25. Yeah, all right, so that looks good. Now you do always want to check both, because it's very possible to get one working and not the other one if you made a mistake in the middle of the problem. That happens actually quite a lot. 1 parent, 2 kids, so we have $6.75 times 2 is $13.50, and then $11.50 for the parent is indeed $25. All right, great, that looks good. If you couldn't follow what I was doing there in my head, feel free to just type it into a calculator, right? Like that's what you're going to want to do on a test anyways. Calculator, not in your head when you're nervous on a math test. So plug it all into a calculator, but do plug it in, right? Check to see if what you are doing makes sense, or if the answer that you got makes sense. All right. One more. This one is going to be going to use the interest. I'm going to use the interest formula. So I'm going to use simple interest here. So the way you calculate interest is I equals PRT. So I is interest, amount of interest, P equals principal, or amount invested. Or in the bank account or whatever. R is interest rate in decimal form, not percent form. So if your interest rate is 2%, R is 0.02, not 2. And then T is time, usually years. And we need that formula for this problem. So here's the problem. Janet invests $5,000 in 2 accounts for 1 year. We're going to go to the next page here. Account A earns, what do I have, 3.1%? 3.1%. And account B earns 6.7%. 6.7%. If Janet earns $299 total in interest between the 2 accounts, how much was in each one? Okay, so there's a lot to take in here. So let's back up and start at the beginning. Janet has invested $5,000 in 2 accounts for 1 year. First account, she gets 3.1% interest, and the second one gets 6.7%. If the total interest was $299, how much was in each account? So I don't think this is too tricky to understand, but picture a pile of money. I like visual representations of things. So I want to picture this pile of $5,000, right? And she's going to split it up into 2 pieces, right? We're going to divide it into 2 pieces. This one's going into account A, and this one's going into account B. So that's what I'm going to draw. I got my pile of money, or Janet's pile of money. Pile. There, money. And then she is going to split that up into 2 accounts. Right, we're going to divide it right there. And this amount on the left is going to go into account A, and the amount on the right is going to go into account B. And account A had, I forget, 3.1%. It was 3 point something. 3.1% and 6.7 for B. So this had 3.1% interest, and this one had 6.7% interest. Okay. Ant on my screen. Go away, Ant. Sorry. And so we need to figure out how much A and B are. So I'm going to let A be the amount in account A and B be the amount in account B. Unsurprisingly, since we're looking for the two amounts, let A, and I don't know what they are, so I'm going to call them something. A equal money in A, and B equal money in B. Okay, so we know a couple of things about A and B. The first thing that we know is that Janet invested $5,000 in these two accounts. So that must mean that the total pile, this whole thing, is 5,000. So I must have A plus B is 5,000. Then the slightly harder one to equation to come up with is going to be this interest one. So account A earns 3.1% interest. So we're going to have to figure out what that means exactly. So here I've got account A earning 3.1% interest, but I don't know how much interest it actually was. However, I do know this. So P is the dollar amount invested in account A, which I have called, unsurprisingly, A. Right? A is the amount invested in account A. So that's principal. That's this. The interest rate, I know that one. The interest rate is 3.1% or 0.031. And the time is for 1 year, so for both of them. So T is 1, so I can just ignore T. So what I've really got is that the interest from account A is the amount in A times 0.031. Let's go write that down. Interest in A, so I sub A is the amount in A times the interest rate, 0.031, times time, which is times 1, which I'm just going to pretend isn't there. This is 0.031A. And similarly, the interest in B is going to be the amount invested in B times 6.7%. So interest of B is going to be 0.067B for the exact same reason. And my total interest was some number, $299. Right? So Janet earns $299 in interest between the two accounts. So if I add those two interests up, I should get $299. And that is my other equation. 0.031A plus 0.067B is $299. All right, I think I can work with that. So let's take these two equations and stick them on a new board so that we have a little bit of room, and then decide how we're going to attack this. So A plus B is 5,000. I'm going to space this one out. A plus, I just said I was going to space it out, plus B equals 5,000. And 0.031A plus 0.06, that first one was not a, there we go, equals 299. Okay, so we can use either method to solve this. We could solve for, we could do substitution, and if we were going to do substitution, I would solve for either A or B in the first equation, because it doesn't have these nasty decimals. And if I'm going to do elimination, I can just choose one of these variables to eliminate and say multiply the top equation by like negative 0.031 or negative 0.067. They both work fine. I generally like doing elimination a little bit better. I don't know if that's my my history of linear algebra where you do a lot of elimination, but that's the one I prefer. So I am going to eliminate A by multiplying the top equation by negative 0.031. And by the way, I'll give you a little tip. If you have something like this, and by the way, this like a plus b or x plus y equals a number comes up a lot. You actually, that's probably the single most common equation that you see in these. If you have that, the easiest thing to do is to eliminate the smaller one because it gives you less negatives, right? I'll show you what I mean. So I'm going to multiply a plus b equals 5,000 times negative 0.031. Negative 0.031 times a plus b equals negative 0.031 times 5,000. All right, so the left side is pretty easy. We just distribute that. Negative 0.031a minus 0.031b. Now let's talk right side. And this looks like a nasty multiplication to do, but it's really not, because I'm going to use that trick that I showed you guys before several topics ago, where I'm going to move this decimal 1, 2, 3 places there, and this one 1, 2, 3 places that way. So 0.031 times 5,000 is the same as 31 times 5, which is much easier. And I'm not going to forget the negative either. So 31 times 5, 30 times 5 is 150. 1 times 5 is 5. So I got 155. So this is negative 155. There we go. Not so bad. And then I'm going to add on this equation right here. It's going to go down there. So we're going to have 0.031a plus 0.067b equals 299. Now, remember what I said earlier about I deliberately chose the smaller coefficient here? It's because I knew that I was going to get, I was going to have a negative here, and that's going to go on both of these. And now when I combine them, of course, the a's go away. But the b's, I end up with a positive number for the coefficient because I picked the smaller one to be negative. The larger one remained positive. So that's 36. So 0.036b equals whatever this is, 155, 299, it's 144, 144. So b equals 144 over, no, there's no way this is right. What? 036. Did I? Well, off by a decimal somewhere? This seems wrong. Anyway, let's see what this comes out to be. So I'm going to multiply by, oh no, I guess this is okay. So I'm going to multiply by 1,000 on the top and bottom to get rid of decimal. That's going to make this a lot easier. I know the numbers get bigger, but the decimals go away. Right, so I want to move this decimal 1, 2, 3 spaces. So I'm going to move this one 1, 2, 3 spaces by multiplying by 1,000. Right, that's what moving the decimal is multiplying by some power of 10. Now I happen to know that 36 goes into 144 4 times. Feel free to calculate that if you want. So this is 4,000. Yeah, I guess I don't have any decimal stuff. That's fine. Right, so feel free to just do 144,000 divided by 36. You get 4,000 if you do. All right, so I got the amount in account B is 4,000, and I can plug this back into any of the equations that we want. This one, or this one, or this one, or most likely, let's use this one, this easy one right here. If there's $4,000 in B, that's going to leave me $1,000 in A. There, that was much easier than multiplying a bunch of decimals. So I guess I will write that out formally, that A plus 4,000 equals 5,000. So A equals 1,000. And then I will check to see if that makes sense back in the original one. So invest $5,000 into accounts. Yes, we got 5,000 total. That's good. Account A, which had $1,000, earns 3.1%. Well, 1% of 1,000 is 10. So 3.1 times 10 would be $31. All right, so I got 31 from A. 1% of 4,000 would be 40. And so I'm going to get 6.7 times 40. So 6.7 times 4 is going to be $268. So that would be 268 plus 31 is 299. All right, great. It seems like I got what I wanted. So I am confident in my answer, and I will say that Janet invested $1,000 in A and $4,000 in B. And that is my answer. And that is all I really wanted to say about solving word problems with systems of equations. Now, let me summarize. And I will tell you that for sure, you're going to get lost in the middle of these when you're starting to do them. Like it always happens. Happens to everybody all the time. There's a lot to see here, right? I couldn't even fit it all on one screen. There's so much to see. So you have to take it a piece at a time. Once I read over the problem and sort of get a general sense of what it's asking, the next thing I look for is, what's the question asking for, right? Janet earns this much in interest. And then the actual question is, how much was in each account? Since I don't know the amounts in the accounts, those are my variables. So once I identify what they're asking for, I go write down the variables, right? A is going to be the amount, the dollars in A, and B is the dollars in B. Very simple. I try and get some sort of visualization of whatever problem I'm doing. So in this case, I'm taking a money pile and I'm dividing it into two pieces, right? And I know it's silly to visualize like a pile of ones or pile of pennies even, like getting split into two pieces. But it helps you because once you do that, once you know that like, okay, my pile was $5,000 and I'm splitting it up into two pieces, what do I know? Well, I know that A plus B was 5,000, right? That one is free just from visualizing. At least for me, it was from visualizing. I don't know if it, you know, maybe you get that from just the words, right? Invest $5,000 into accounts. That also means like A plus B is 5,000, right? But to me, it's easier to see when I think of it like this. And then the rest of the problem, right? There was a whole bunch of other information, and obviously your other equation is going to come from the other information. So count A, 3.1%, count B, 6.7%. And then I'm going to need to turn that into some kind of equation. And so here I actually have to know this formula. And by the way, I will expect you to know this formula. This is a thing that we're going to use, or you will use a lot just in general in your life, is how to calculate interest. And so I'm going to try and mix a few of these into problems in the future. I'm going to go out of my way to use this just to help you get good at percentages. And so, yeah, memorize this formula, I equals PRT. You can also just think of it as amount you invested times the interest rate. That's how you get amount of interest. We're not going to worry about the T right now. I'm just going to make that 1 every time. And then use that idea of, well, I know the interest in A and I know the interest in B, and they told me what the total interest was. So that's very similar to this equation, right? Where I know the amount in A, the amount in B, and the total amount. I know the interest in A, the interest in B, and the total interest, right? So we can set up the equation in pretty much the same way. So this is a little bit more complicated, but not tremendously more complicated than, say, this one with the Lopez's and the Smiths. It's still the same idea of I have a certain amount of something that I'm multiplying by, like the thing I'm looking for, well, I had 2 here and 3 there, 2 kids and 3 adults, and the total cost was this, right? It's still the same idea of multiplying 2 things together to get the value, right? I multiply the number of adults times the cost of an adult ticket to get the total cost of adult tickets for the Lopez family. And I do the same thing, number of kids times the cost of a child's ticket to get the cost for children's tickets for the Lopez family. And I add those together to get the total cost for the Lopez family. And that's the sort of thing that you're going to be doing a lot in these problems, is figuring out what value you are looking for and then trying to make a kind of a smaller calculation of it. And the important thing here is, well, I'm saying this really awkwardly, I'm sorry. The important thing here is amount times quantity, value times quantity gives you total amount, right? So the value of an adult ticket times the quantity of adult tickets I bought gives me total cost of adult tickets, or cost of adult tickets. And then same thing for the kids, and then there's the total cost. In the same way that, come on. Interest rate in A times the amount in A gives you the total interest in A. Interest rate in B times the amount in B gives you the total interest in B. Add them up to get the total overall interest. Right? That's a very common thing that you end up doing in these is, like I said, amount times value to get total value. The other thing I wanted to point out here is this. When you're making these equations, it can be easy to mess up making them by, I'll get a lot of people doing like A plus B equals 299 and 0.031A plus 0.067B equals 5,000, like swapping those two things because they're not keeping track of which one means what. One way to help yourself keep that straight is that these two equations are about different things. This equation is about money. This equation is about interest. And I know money's a little maybe too general, but it's about principal is really what I should say here, right? The principal in A plus the principal in B gives you the total principal, and the interest in A plus the interest in B gives you the total interest. So don't mix those things is what I'm trying to say. In the same way that you wouldn't like mix the Smith family and the Lopez family, right? We wouldn't do the Lopez family, and then the Smith's cost. Like that doesn't make any sense, right? Lopez adults plus Lopez kids equals Lopez total. And Smith adults plus Smith kids equals Smith total, right? So this is about the Lopez family and the Smith family. Right? And so that is a thing that happens very often in these problems, is that your two equations are about two different things. And if you can keep them straight, it makes it pretty easy to actually figure out what the equation is. Okay, I don't want to say too much more. I want to just let you guys practice instead of rambling at you forever here. So I'm going to go ahead and stop there. And when you inevitably get stuck on this stuff, come see me. All right, I will see you guys in the next video.